Okay, so today we're talking about, basically this is useful in battery assignments, but this is going to be reduction half reactions, and one of them gets turned around, and then we're going to have oxidation reactions, because one thing has to be reduced for another to be oxidized, because electrons have to go somewhere, they can't just not go anywhere. So basically, we're looking at which substance is the strongest reducing agent and which is the strongest oxidizing agent. So basically, you can see right here I have this table, and so this is going to be all of the, so these ones are all going, D minus is oxidized, and it has electrons, so it's going to be the reducing agent because it's giving electrons strongly. And so basically you can see that D minus is the strongest because it gives up its electrons the most strongly, and so it's the best reducing agent. And the reason for this is basically they with the electrons, because basically like they want to hold on to those electrons, and so like the reduced things are going to take the electrons and hold on to them. And so basically this, you can see that this is the reduced form, and so you can see the thing that's reduced the best, the most strongly, is the best oxidizing agent, because it itself gives up, or it takes, excuse me, so the best at being oxidized, or the best oxidizing agent is the best at being reduced. And so it can help something else be oxidized by pulling these electrons strongly at 1.47 volts. And basically you can see these things are spontaneously oxidized if the number is greater than 0 for the voltage. And so basically like D minus, you can see it itself basically, so B2 plus, you can see is at 60 volts, and so basically if it is going to have something else be oxidized, and so it's reduced, you can see it's got to be greater than 1. So this plus C plus and plus D minus both are greater than 0. And then to be spontaneously reduced by C plus, you're gonna have this 0.21, and it's got to add up to be greater than 0. So this plus you have B, and then B, and then A plus is going to be 0.60 and 1.47, which both are greater than 0. And then basically it says write the balanced reaction that delivers the highest voltage. So basically it's going to be the cell potential is the cathode minus the reduction potential of the anode. So we're going to find the cathode, which basically is whatever's reduced. And so we're going to have the cathode is going to be A plus is 1.47, and then we're going to need to balance it. And so these two electrons are going to go somewhere. So it's going to be the 0.21 because it's the smallest. And so that is going to be times by 2 for the 2 electrons, and that is the balance of that. And then to find the calculation for it, it's 1.47 volts minus the 2 times 0.21 minus 0.42, or 1.05 volts. Thanks for watching.